the last several videos, we looked at how to find resultant vectors by looking at displacement. And so this time we're going to see that any vector can be added through the methods that we've been looking at. In this case, we have velocity. Velocity is also a vector. It has direction and it has magnitude. In future lessons, we'll be looking at force and using vectors for that as well. So this particular problem comes from the section review on page 94. This is number 2A. Find the magnitude and direction of the resultant velocity of a fish swimming at 6 meters per second relative to the water across a river that moves at 5 meters per second. Again, we're going to start with a drawing. Now, what they're telling us is this fish swims at 3 meters per second if it was swimming in still water. And so let's draw our fish's velocity vector. It's going 3 meters per second across this river. Now the implication is that it's going directly across the river, but the river is moving at 5 meters per second. Now they don't tell me what direction the river's moving, so we're just going to describe it according to the way we draw it. Okay, so he's crossing the river perpendicular to the current. And do you remember what we do next? How do we find our resultant? Where is our resultant? Well, our resultant vector is going to be this vector here. Okay, so here's our resultant vector. How will we find the magnitude and direction of this vector? Well, the magnitude can be found by using Pythagorean theorem because this is a right angle. So we have a squared plus b squared equals c squared. 5 squared plus 3 squared equals 25 plus 9. What do we have here? Once we take the square root of that, we're going to get 5.8 meters per second. That's the magnitude of my vector, 5.8 meters per second. Now I know how fast the fish is moving. Remember, this time we're talking about its velocity. I know how fast it's going, but I don't know in what direction. Now I can tell from my drawing that it looks like in this particular case it's going a little bit east of north, or we could say that it's going right of the vertical. There are several ways we could describe this, but let's take a look at this angle down here, and we're going to use that to describe the motion of the fish. Okay, so we know our opposite side, because this is opposite of the angle theta that we're looking at. We know our adjacent side. Now we calculated our hypotenuse, but we don't necessarily want to use that one, just in case we made a mistake. So when we have opposite and adjacent, we're going to use tangent, because the tangent of theta is equal to opposite over over adjacent. Opposite over adjacent. And remember that what we're doing is we're taking the inverse tangent, because what we want to know is theta. So we're going to do the inverse tangent of our opposite, which is 5, divided by our adjacent, which is 3. Take out our calculator. Second tangent, 5 divided by 3. Make sure it's set on degrees. And we get 59 degrees for our angle theta. But how are we going to describe that? If the fish is moving downstream, which is the way it's kind of pointing, we could say that it's 59 degrees downstream. We could also describe it to the right of the vertical. So our magnitude is 5.8 meters per second. And the direction is 59 degrees downstream. So this tells us the direction the fish is moving. It's not going straight across the river, it's moving slightly with the current and going at an angle.